everybody, welcome back to the channel. I'm actually recording this intro after I actually put the video, or I had done most of the recording already. I wanted to just point out a couple things. In the editing process, I've noticed that the sound quality varies a little bit. I feel like none of my videos have very good sound quality. Like my microphone is not all that great, and my computer itself is not that great, neither is my recording software. I mean, I'm recording this on a laptop. The sound, like the background noise, goes kind of in and out a little bit. It's because it's wintertime, and I have central air conditioning, so the vent, you can hear the fan blowing in certain parts. I'm also recording in a room that's right near a window, so like there's traffic that goes by when cars drive, you know. But if it really only makes a difference if you're listening to this on headphones. If you're listening to it otherwise, then you probably can't really tell the difference. I don't really have good software to edit like the sound quality. I've said it before, I'm not a YouTuber, so I don't have like a soundproof room. I don't have like a really good quality microphone. If you can see past like some of the audio quality not being like stellar, then I think you'll still appreciate the video. So what this video is really addressing is Terence Howard's proof, his kind of revamped proof that 1 times 1 equals 2. So let's go ahead and get started. First of all, this comes from his book. It's a section of his book called The Unbalanced Equation, but it's very much like the proof that, like the original proof that he put on the website formerly known as Twitter. Let's be honest, it's the website still currently known as Twitter. Nobody calls it X. And I'm going to use the same system that I used in my previous peer review videos where I'm highlighting stuff in green if I feel like it's correct, stated correctly, or something, if it's a brand new idea, something that I can get behind, that I can agree with. I'm highlighting in pink if it's incorrect or I disagree. I am highlighting in yellow if something is not incorrect or correct, but just confusing, which tends to be like the bulk of his writing. I know when I went through my previous peer review videos, yellow was used probably more than any other color. So once again, this is I'm going to go through his entire proof. He changed some things about it. I noticed he took out like the Anunnaki. He took out a reference to the Anunnaki. So anyway, if you're already a fan of this channel, or maybe if this is the first of my videos that you've seen, first of all, welcome. Again, like just bear in mind, I don't really make these videos for anyone other than myself, just as a hobby. And to, I think I find it really interesting, and I'm kind of like, it's just fun. It's funny. Reading his writing is hilarious because it's so bad. It's like when when we watch a movie that's just like it's so bad that it's good. So let's take a look. Balance. He's got an image here that is of a bunch of stones. It doesn't even look balanced. I'm not sure how he made this. It looks like maybe it was like photoshopped or something. I mean, there's some shadowing here on these rocks. The beach doesn't look quite right. It's not AI generated because I believe, if I'm not mistaken, he released this book in 2019 originally, like the first draft or whatever. I wonder what the first draft looked like. Like, because the one he has on the internet now is supposedly he went and improved it. And even this is an improvement on the original proof from Twitter. But what I'm saying is he definitely didn't use AI to generate this image because in 2019, AI image generation was kind of in its infancy. As far as I know, like I'm thinking back to 2019, it's 6 years ago now. And I don't think that people were really using AI image generators. And he definitely doesn't know how to, he doesn't really know how to use software at all. I mean, he thinks Blender is like simulation software, even though it's animation software. And he doesn't even ever use it himself. He has like one of his friends do it. So this was probably photoshopped by a friend of his. I don't even know how I put together this book originally because it's real sloppy. It's got, I copied and pasted it into OneNote so that I can, annotate and draw over it. But it's on a PDF. I'll put the link in the description so you can go check it out if you want to. if you want to go read it at your own pace. So he's got balance, and then he's got a reflection of the word balance written in a real fancy font. If he really wanted to make these like opposite, he would have actually used opposite colors on the color spectrum. Like he could use like a green and then a red, right? Those would be opposite. Those would be that'd be cool for a little reflection here. So as I go through this, I'm kind of criticizing his style choices as well, but to a lesser of an extent, because what I'm really qualified to criticize is the mathematics. I have a degree in mathematics. I've been a mathematics teacher for many years. I've written curriculum in mathematics. All right, so this starts off with a quote here from Walter Russell. The keystone of the entire structure of the spiritual and physical universe is rhythmic, balanced interchange between all opposites. That's a quote from Walter Russell, the godfather of word salad, and someone who Terence Howard credits and quotes as being an inspiration of his. He wrote a book called The Universal One. That's probably where this is from. But, you know, when you read Terence Howard's writing, this might give you more of a hint of where he gets some of the way that he writes about science, about quote-unquote science. If you read a bunch of word salads, you're probably going to write a bunch of word salads. It makes sense. So this quote really doesn't mean anything. I mean, read it for yourself and tell me if that means anything to you, because I can't get anything out of it. I tried actually reading parts of his book, The Universal One. It's almost unreadable, just because it's a bunch of stuff like this, where you have no idea what it's even about. It's a lot of words that they all have meaning. And look, he even capitalized, like randomly, kind of arbitrarily capitalizing words for no reason. I think that Walter Russell probably did that as well, and that's why Terence Howard does it. But, you know, earlier I was talking about AI. I was talking about how this image is probably not AI generated because AI generated images were just not very common in 2019. But he definitely didn't use AI to write the contents of this book. And I'm saying that because when you read parts of this book, you can literally hear it in Terence Howard's voice. If you imagined him actually speaking these words, it would make sense, like in his voice, in his accent. So he definitely is the author of this. Like, I have no doubt that he wrote this book by himself, and nobody helped him, because it sounds like the way he talks in interviews. You can literally hear his voice sometimes as you read the words. All right. Unbalanced equation with 1 times 1 equals 1. So even the title I can highlight. I disagree, because 1 times 1 equals 1 is a perfectly balanced equation. Definitely not unbalanced. First and foremost, let us ask the most obvious question. Is 1 times 1 equals 1 a finished equation? I would say yes. Yes or no? The answer is no. All right, that's wrong. Why? Because it's not even on both sides. Okay. That's a little confusing. It's not even on both sides. Does he mean even as in an even number versus an odd number? Because that means something. Or I'm assuming he means balanced or the same, and that is wrong. It is actually balanced. Yes, nature desires action but demands equilibrium. Therefore, in order for an equation to be considered finished or completed, both sides of the equation must be equally balanced. Okay. That makes sense. I like that. He is totally telling the truth there. Yet, in the case of 1 times 1 equals 1, we have an unfinished equation. So, okay, unfinished is an undefined term. That doesn't mean anything. He made it up. I also highlight stuff in yellow when he just makes up words, or he makes up terms and he pretends like they're actually actual terms, which he does quite frequently. Because we have 2 1s on one side of the equation and 1 1 on the opposing side of the equation. So, wow, that's his reasoning for why it's not balanced. So he's ignored all arithmetic operations. I mean, what about something like 1 equals 1 divided by 1? Okay, when you divide 1 by 1, you get 1. So there's 2 1s on the right side of this equation. There's only 1 1 on the left side. I mean, even with like minuses, you could do, I can say 1 equals 1 plus 1 minus 1. So would he disagree with that? You take 1, you add 1, subtract another 1. These two things cancel out, the plus 1, the minus 1, so you're left with just 1. And this is a perfectly balanced equation as well. But there's 3 1s on the right side, and there's only 1 1 on the left. So it really doesn't make a difference how many of what number 1s you have on one side of the equation, because, again, you have these things called arithmetic operations, which is plus, minus, multiply, divided by, even taking a root, taking a square root, or raising to an exponent. Those are all operations. We can't ignore operations. We can't just say, oh, let's count up all the 1s and see if it's balanced. It doesn't make any sense. Let's attempt to balance this equation. First, by making sense of it. Come on, let's label the relative factors. It's so difficult to read this book. It's not like it was written for children. It's like it was written by a child. So label the relative factors. Okay, so factors is referring to two things that are multiplied to get another thing. Like when you multiply two things, those are called the factors. And then the end result is called the product. So he's labeling C here as a factor, even though that's not a factor. Wow. We will call the first value A, the second value B, and we'll call the third value C. Wait a second. Hold up. These are the same value. So why is he giving different names, A, B, and C, to the same number, the same value, right? He agrees that 1 is the same thing as 1, yet he's just giving them all these different names. I think, so at one point of his life, he must have come across some math somewhere, like algebra, and he was like, oh, I know what we do. We normally we replace letters and numbers, and we'll put letters instead of numbers. What he doesn't realize is that the reason we do that is to be more general. So if I could say, let's take the commutative property, for instance. Like I say, 2 plus 3 is the same as 3 plus 2. That's an example of, or an instance of, the commutative property. It means when you switch the order, if you're doing addition, it doesn't matter, you still get the same result, right? This is still going to be 5 on the left, 5 on the right. So that's like one instance of that problem. What we can do to make it more general, and that's what we do with algebra, is put letters. Like we'll do A plus B equals B plus A. And if I want to get fancy with it, I can say for all A and B in, I could say the real numbers, the natural numbers. It applies for many different sets. So the thing is, you can replace A and B here with any numbers that you like, and it will always work out. That's kind of the whole point of putting letters, of making symbols and letters represent numbers, to be more efficient, right? Now, this thing that I've written here in green, now that applies to not just 2 and 3, but it applies to 5 and 8, or not, any numbers that you can think of. 5 plus 8 is the same as 8 plus 5. So that's the purpose of using letters and labeling stuff instead of numbers, to be more efficient. What he's done, he's actually gone backwards. He's now he's now giving the one value 3 different names. Wow. So this is like the least efficient thing ever. Does that make sense? He did it backwards. Like he knows to label stuff or to use letters but he doesn't understand why we do that in algebra. And another purpose of these videos, besides just laughing at Terence Howard, is also to, throw in a little bit of math instruction. This right here, hopefully I've explained to you the purpose, the reason why we use letters to represent, any number, like a variety of different numbers. He is like, oh, let's just take one single number that we already know the value of, and we'll just put a letter next to it and call it that. It doesn't make any sense. So what does he mean when he says, here, let me get my yellow, this is real confusing. What does he mean is that the first value, the second value, and the third value, they're the same value. These three things have the same numeric value. So why are you giving them different names? It's completely nonsensical, and it's, instead of saving time by using letters, he's actually wasting the letters. He's using them all to represent the same thing, which doesn't make any sense. Remember the basic laws of common sense. Okay? There is no such thing in mathematics as the basic laws of common sense. There's the commutative property, there's the associative property, there's the identity property. There's a lot of different properties of numbers. There's nothing that's just called the law of common sense. Even in logic, which gets more abstract, and you'd have things like, the law of contrapositives, and you have modus ponens and hypothetical syllogisms and things like that. Even logic doesn't have anything called the laws of common sense. That's not a real thing. So I guess maybe I should put a yellow because he made it up. Ooh, that's a nice little color. Okay, if A times B equals C, then C must be some product of A and B. Okay, yeah, that's what the word product means. Sure. So that's just true by definition. Yet in order for 1 times 1 to equal 1, the value of either A or B has to be missing from the final product of C. So that's definitely not true. Has to be missing. No. Nothing's missing. There's no big conspiracy here. He just forgot. He doesn't know what arithmetic operators do, or what they mean, or why we use them. Okay, let us simply apply the associative and commutative law to the initial equation. Oh my god. So, wow, so this is actually good. I just talked about the commutative law, or the commutative property, you can call it whatever you want. It's right here. A plus B equals B plus A for all A and B. It also works for multiplication. There's some other operators that are also commutative. It just means you can switch the order when you're doing that operation, and you still get the same result. He thinks that the associative and commutative properties are the same thing. They're not. They're not. Here, let me scroll up again. I guess I can color code it. So this one right here, let's see, because I have a room here. This is the commutative property. Okay, for addition. Again, it works for multiplication as well. And if you get more into abstract algebra, you can even define different operations, and you could tell whether they're commutative or associative. Associativity, let me do another purple. Associativity, or the associative property, looks like this. I'll do it with addition again. A plus B plus C is equal to A plus B plus C. And usually when I explain out the associative property out loud, I usually just pause my voice a little bit. So here's what I mean. A plus B plus C is the same thing as A plus B plus C. The parentheses make a difference. The associative property is saying that the parentheses really don't make a difference, but what we're saying is that it doesn't matter what order you perform these operations in, you'll still arrive at the same result. So I can also put, for all A, B, and C in the real numbers or the natural numbers. Again, Doesn't really matter what set you choose, but I'll just go with the real numbers. So once again, that's the commutative property, that's the associative property. They're very different. They're extremely different. Associativity does not imply commutative. If something is associative, it doesn't imply that it's also commutative, as far as operations go. He thinks they're the same thing. That's why he always refers to them like as a single item. He says the associative and commutative law. I'm surprised he spelled commutative correctly. All right, 1 times 1 equals question mark. Okay. So he does get what the reason why we use some symbols, right? He knows that if we don't know a certain value, we'll use a symbol for it. In algebra, we normally say X or Y, or even use like Greek letters sometimes. He decided to use a question mark, but that's the same idea. He's using a symbol to represent something that's, in this case, unknown. What's interesting here is that I've also used a symbol, these symbols here, A, B, and C, to represent things that are not unknown but are arbitrary. It works in every case, but that's why I label it as, I put in there for all AB and for all A, B, and C. It's like so much of when you read his stuff, some of it, he's like on the cusp of understanding, but he never quite makes it. It says here, add A to itself as many times as indicated by units in B. Since A has 1 unit and B also has 1 unit, then 1 times 1 doesn't equal 1. 1 times 1 and 1 plus 1 both equal 2. I did extract this when I did my 1 times 1 equals 2 fully debunked video, and I pointed out how this cannot be a true statement. 1 times 1 and 1 plus 1 cannot both equal the same thing, because it would violate something that we call the fundamental theorem of algebra. If you want a more in-depth explanation of that, you can see my video 1 times 1 fully debunked. It was one of my more popular ones. All right, since they're both doubling their value, and it follows, and since they're both doubling their value, then it follows that they are different expressions of the same function. Oof. So, circular logic, circular reasoning. Right, he makes a statement that's incorrect, and then he says, since. He used the word since, so he's like, oh, because that thing that I just said is the case, because it's true, here's something else that logically follows. But the original assumption is not true. So he's using circular reasoning. He has not proven that this is the case. There's nothing at all that proves that. I think he believes that this statement here proves it. Whatever this statement even means, he must have copied it from a book at some point, probably a really low-level math book, like made for children, because it's not stated correctly. You don't add as many times. You wouldn't. He's thinking that you would add 1 to itself, and that's what 1 times 1 means. No. If it was times 2, that would mean, so again, multiplication is, you can think of it as repeated addition. For like the natural numbers, for whole numbers, you can be like, okay, if I have 1 plus 1 plus 1 plus 1, the reason we have multiplication is you basically count these up, 1, 2, 3, 4, and it can write it as 1 times 4. And it's just a simpler way to say, okay, there's 4 different ones that are being added together. So this is sloppy. I don't like the way he said that. Both different expressions of the same function doesn't mean anything. Function means a lot in mathematics, and if you're a math student, or if you've recently been in like college algebra or even high school algebra, you'll know that like functions are really important. And then if you get even higher in math, you learn even more about functions and how they're kind of different. They're a little different than the way you were taught in high school. I'm not really going to get into the weeds right now, but I don't say function. It's not the right word. Like, stop doing this. Because the thing is, he uses words that actually mean something incorrectly. And he uses like a lot of like euphemisms or like, he thinks that it's just a figure of speech is a good way of saying it. But they're not just figures of speech, they're actually mathematical statements. And something like a function, different expressions of the same function is nonsensical. It doesn't mean anything. For the sake of time, let's go ahead and continue this in the next part. I'm not sure how many parts I'm going to break this up into, but if you like the video, please give a like and share it out. The main reason I ask is the more likes it has and the more subscribers I have, then this gets higher in the algorithm and then more people watch it, and as far as they've told me, they enjoy it. I get a lot of good positive comments and other people that are also, sick of Terence Howard spreading his insanity and just being a jerk, because he's not even humble. He's not even like, oh yeah, no, I have all this knowledge and you don't. He kind of just, he uses it to talk down to people and just be an incessant imbecile. I do want to also make a note that this video is not bullying in any way. It's not meant to be a criticism of Terrence Howard's character. It is just meant to be a criticism of his ideas and his writing. And that's perfectly fine. That's allowed on YouTube. Please like and subscribe. And we'll see you in the next part.